Hello, welcome to HED5060, Principles and Practices of Effective Teaching. This week we're talking about lectures for learning, and I'm Philip Dawson from the Office of the Pro-Vice Chancellor, Learning and Teaching at Monash University. So, here we have it. Bly says, one of the most common mistakes by lecturers is to use the lecture method at all. It is kind of an assumed thing that we have lectures. I mean, this right now is a lecture. I hope I'm not making a mistake by doing this. I think we'll discover that there's some sound reasoning behind this lecture and the design of it, but yeah, let's find out. So this week, we'll start off with some homespun truths. We'll talk about what are lectures good for. We'll return to Bly. We'll talk cognition in lectures. So how does the brain work during lectures? And we'll talk about active processing, getting students to actually do stuff with what we're presenting in lectures. Last week we talked about feedback, its role in improving practice, who can give feedback, formal, informal feedback, and giving, receiving, soliciting, acting on, and the ethics of feedback. Hopefully now you are actively involved in getting some feedback from your students. I know you've been actively giving me feedback and I've really appreciated it. Last week we had this broad diagram with a whole bunch of stuff on it representing sources of feedback for us. I know that between all of us, all the people that I talk to, there's this broad sum of feedback and some other sources we hadn't even thought about. But let's start today with some obligatory homespun wisdom. These are not evidence-based truths. These are tales, fables, stories about what it is to do a good lecture. Well, what do? You speak clearly. You try and get rid of that nasally voice that you've got or something. Speak a bit slower. You be nice. I'm a nice person. I hope you can tell this through the lecture. You're nice people. You can project this to your students. You show enthusiasm. That's hard for me to hide here. I am genuinely enthusiastic about this, but one of the homespun truths of lecturing is be enthusiastic. If you're not, fake it. Plan ahead. Make sure you've built up some sort of lesson plan. Have less than X slides, where X always seems to be less than the number of slides I usually tend to have. There's generally not a science behind that recommendation either. Make eye contact. Make sure you make eye contact with your students. Tell jokes. Cater to the visual, auditory, kinesthetic learners. Include some push-ups in the lecture. Include lots of fascinating anecdotes. I heard an anecdote once. It was really interesting. And, other stuff. There's a whole array of stuff that will allegedly make you a better lecturer, and guaranteed some of it will. I'm trying to restrict this lecture today not to my own personal experience of, what it is to do good lectures or to do bad lectures, but I'm trying to restrict it to things that are somewhat evidence-based. So I'm not going to focus on these things, and I'm actually going to explicitly tell you that learning styles do not exist. One recommendation I can give to you is don't waste resources adding stuff, visuals, audio, text, dancing, solely to cater for different learning styles. We do have some resources up on the Moodle right now about how you might be able to use visuals to help people learn better, yes, but those are for everyone, not just for the visual learners. That said, if you disagree with me, you can get yourself $1,000 if you can prove that learning styles exist. There's a link beside this video. There's currently not an evidence base to suggest that these things actually exist. So yeah, you do the research, you prove it, you win yourself that $1,000. Until then, my recommendation, don't develop your lectures around an understanding of visual, audio, kinesthetic learners, because the evidence just isn't there. We return back to our catchphrase, learning is what the student does. And today our goal is to try and get students to do stuff, both cognitively in their own head, themselves thinking about this stuff, and also actively with other people in the lecture space. I guess the catchphrase for this lecture is content covered is not content learned. I have lofty aims, but I actually don't expect you are going to learn every single word in these lecture slides. If I believed that content covered was content learned, this lecture would have about 500 text-heavy slides, because then you'd learn a lot, but we both know that that doesn't happen. And I guess another axiom is that lectures are not always bad. Lectures cop a fair bit of flack lately. They're not always bad. So what is the use of lectures? And this comes from Bly's exhaustive review of research, admittedly a little bit dated, about a decade old now, but quite a thorough review on studies that compare lectures to other modes of teaching. And the lecture mode is as effective as other methods to transmit information. So this is the lecture's strong point, transmitting information. If you want the students to learn stuff that you are transmitting to them, the lecture can be a really effective way to do it. And we also know it can be quite efficient as well. You know, you can fit 2,000 students into some of these lecture theatres. Pretty efficient stuff. But most lectures are not as effective as discussion to promote thought. And lectures are actually ineffective for social or personal development, to teach values, to inspire interest, to teach behavioural skills. So if the goal of your class is to transmit information, lectures are no worse than other forms of teaching. If you have the goal of promoting thought in your students or getting them to change somehow, to develop, to acquire the values of your discipline, you know, the values of being a teacher or a nurse, think about ethics, inspire their interest in the topic, or teach them skills that they can do, then the lecture is not a fantastic tool. So we're going to focus on lectures that have the goal of transmitting information, because it would be suboptimal to have us focus on those other things when they're not really what lectures are good at. So for this lecture, let's focus on transmitting information, about transmitting information. And let's start off with some controversy. Transmission teaching cops a lot of flack. It's kind of unsexy. So here is an article, and it's linked to on this Moodle. Why minimal guidance during instruction does not work, an analysis of the failure of constructivist, discovery, problem-based, experiential and inquiry-based teaching. There's a broad brush of a lot of trendy teaching methods and their failure. So people bag out transmission teaching, people also bag out these. Let's see the abstract of that. Now the abstract, it reads, although unguided or minimally guided instructional approaches are very popular and intuitively appealing, the point is made that these approaches ignore both the structures that constitute human cognitive architecture and evidence from empirical studies over the past half-century that consistently indicate that minimally guided instruction is less effective and less efficient than instructional approaches that place a strong emphasis on guidance of the student learning process. The advantage of guidance begins to recede only when learners have sufficiently high prior knowledge to provide internal guidance. Yeah, bad lectures can still be bad. That's a bad lecture. We've been there before. I know I've delivered that sort of bad lecture before and I feel terrible about it. And I anticipate you've been involved on some end of the equation with this sort of lecture before. So content covered is not content learned. I challenge you to think back to anything on that previous slide and what I was actually talking about. We're going to go to cognitive load theory, which is actually kind of the topic of that article. But we're going to try and talk about the theory rather than my terrible discussion then. You might have heard this 7 plus or minus 2 thing. It's sort of spread like one of those truisms of education, or an axiom, that people can hold in their head roughly 7 things plus or minus 2. Maybe 5, maybe 9 things, but somewhere in that broad scheme of things is what you can hold in your head. And this might actually have an impact on pacing. So if we have a limitation of working memory, we may wish to pace things such that we don't overload working memory. Sounds reasonably intuitive. But expertise is what influences what a chunk of that working memory is. Now, I play guitar. For me, the F chord is one chunk of working memory. However, for a novice at guitar, the individual notes that make up the F chord might be a chunk of working memory. So if you're doing a chord that requires 4 fingers, there's kind of 4 chunks of working memory for you that might be 1 chunk for me. An expert chess player, a chunk of chess might be a subsection of a chessboard, whereas for a novice chess player or someone who's never played before, the positioning of any individual piece might be a chunk of working memory. So expertise allows us to build up these schemas of what something is and kind of automate things into one chunk that might actually be many discrete things. If you see that first word there, cognitive, you don't see that as COGNITIVE. You wouldn't memorize that as 9 chunks. You would memorize that as 1 chunk, the word cognitive. If you've heard the words cognitive load theory before, that might even be a chunk. So we have this idea we can hold 7 things plus or minus 2. Expertise impacts on that. We need to consider the expertise of our students in considering pacing and working memory. We also need to consider words and visuals. So we have a couple of channels going on. We have a primarily linguistic channel that's concerned with words. Spoken words, written words, kind of use the same channel. We also have a separate channel for visuals, so graphs or diagrams that explain things. Cognitive load theory supports us using words and visuals together. We also have an idea of seductive details, those interesting anecdotes, the fascinating bits that aren't actually relevant, that consume chunks of that working memory. So cognitive load theory is concerned with managing that working memory. Let's look at some application. So we have this idea that bad lectures can be bad. So when I was reading this verbatim, that was pretty terrible. And researchers have actually found that that's something we should avoid. In your lectures, avoid reading long text excerpts from slides. Now, if randomized control trials are your thing, you might be thrilled to read that the effect size for this was 1.15 when comparing just reading to reading and having the text there. So the effect size of 1.15, to butcher it slightly, it's 1.15 standard deviations above the mean for people who just had the audio version versus people who had audio and text. This is quite substantial. In education, an effect size of 0.6 would be considered quite good. So 1.15 is really good. So if you really want people to learn something, don't have it huge chunks written up there on your slides and read it verbatim. It will hurt learning. You may want to try narration of short text excerpts with pauses. The effect size for this was 1.62 in favour of audio and short text excerpts versus just audio. So sometimes it's okay to have the text there, just not in the big, huge block quote. And sometimes you might just want to read out the text yourself or just talk. You don't always have to have something there on the slides. And again, that's our 1.15 for audio only versus audio and text. Now, if this sort of thing is something that excites you, I've done a kind of short summary of a few research studies for you up on the Moodle. I've just gone through some of the recommendations for written and spoken text. There's also recommendations for text, graphics, and audio. So how can we use diagrams more effectively? How can we use diagrams with text, with audio? It's up there, some summaries of the research along with some guidelines on how to interpret that type of research. Just another thing while I've got you here. Actually, hang on a moment. I'll just I recorded this tune because I thought it'd sound good. Okay, that's it. I might turn it up. You may or may not be aware, but superfluous but interesting information hurts learning. So having a whole bunch of extraneous text, graphics, audio hurts people's ability to learn the main thing that you're trying to get them to learn. In this slide, I'm sure you can see a number of things. This is actually a part of the corporate Monash default slide. We've got distracting bits of the slide here. We've got a graphic that's not actually related. It might attract your attention, your affective engagement, but it's not actually related to what we're talking about. It's just eye candy. We've got a whole bunch of logos and text, and the text is kind of overlapped by stuff, and you had my lovely noodling on the guitar as well. None of that was actually sort of relevant to the point I'm trying to get across to you. So now I will get the point across. Superfluous but interesting information hurts learning. And students do learn more from less. My advice to you, weed your lectures. Omit anecdotes. Keep examples. What's the difference between an anecdote and an example? An example helps advance students' understanding of the content that you're trying to get them to understand. It's explanatory. It might have working out steps in it. You might provide some commentary on how this relates to the main thing you're trying to get across. The example helps them understand the thing. An anecdote is related, seductive details that the students don't need to know. They're things you know from your mastery of the content. They're things you know from your industry experience. But you haven't found a way to quite incorporate them in with the content, so they sit on the periphery as this superfluous thing. Anecdotes hurt learning. Examples can help learning. It's hard to distinguish between the two, I know, but you'll get a sense sometimes. The anecdotes might be fascinating, and your students might affectively, engagement-y love them, but you've got to think, are they helping learning? Omit extraneous visuals. The terrible, just stock photo from the slide before. Keep diagrams. Keep things that explain what it is you're trying to get across. A really effective approach for a lecture, for a slide, can be to have the diagram up there and to talk about it, to talk at it. Just a diagram on the slide, just you talking. That can be really effective. The extraneous stock photo, really ineffective and hurts learning. Omit detailed quantitative results. If you have a lot of these slides that have a table of values with, 10, 20 different numbers on the slide, are you expecting students to memorize this? Would it be more effective to have that off somewhere else? If we look at how students actually learn things that they're a novice about, they don't learn the detailed quantitative results first. They learn the qualitative explanations. They learn how this system works, what bits feed into what bits. With this theory, what's the main thrust of it? How can I explain it? Not what are the weightings on each of the bits inside of this model. That comes later. So, omit detailed quantitative results, keep qualitative explanations. Omit unnecessary music and sounds. This one's kind of obvious. There is a body of research about how people work and learn with music, and the evidence isn't there to support music helping people work or learn. Instrumental or vocal music, sadly the evidence isn't there. We might like it, but it's somewhere in the order of about 50 words less per hour productive we are. Keep signalling with voice. We don't throw out all of our lovely audio stuff. Your voice and your knowledge and enthusiasm comes across. The words in the sentences that are the most important, you signal which ones they are. You stress them. You gesture. You raise and lower your voice, all of those things. They do work. Omit non-essential material. Try and do that pruning and weeding and figure out what doesn't absolutely have to be here and keep the essential stuff. If we go back to learning being about what the student does, well, how do we get them to do in lectures? The cognitive transmission principles we've talked about here are good for up to about 20 minutes. I can say this is not an evidence-based thing. This is the vibe, this is the experience. There's debate about how long we can get people to be in this transmission mode of teaching without active processing. For more than 20 minutes, always incorporate active processing. This is my tip to you. One such approach is think, pair, share. Pose students a question, get them to think about it. Give them a minute. Tell them you're going to give them a minute, actually give them a minute. They think about it, they come up with their answer. Get them to pair up with someone, give them a minute or 2 minutes and tell them. Get them to justify their response to each other, get them to argue about it. We want this active engagement. And then get them to share. Sharing might be with the whole lecture theatre if you have a smaller class. Sharing might be with a subsection of the lecture theatre. And then somehow you draw this together and do a wrap up. And consider doing an activity like this every 20 minutes. Voting, clickers, live tweets, getting people to tweet along to a hashtag, other technological back channels. These can be great ways as well that are kind of non-threatening. The think, pair, share gets me having to talk. Oh my gosh, this is scary. The voting, clickers, live tweets, etc. A bit easier to manage, a bit easier to get involved with, and a bit, I guess, safer and more anonymous. It's also a way for you to gauge people's understanding. So consider doing something like that every 20 minutes. And problem solving. Take what you've done in class and apply, solve a problem, do something with it. And do something like one of these every 20 minutes. And when you're doing those things, it's important to consider all students' active processing. It's easy to think, I have an interactive lecture, I ask the students questions and they respond. How many students respond? If you have 1,000 students, if you have 100 students, say you've got the 100 and 5 respond each class, likely the same 5. Is that really getting all of the students to do active processing, or is that the 5 up the front? So try not to get into this false sense that I have these interactive engaged lectures when it's you interacting with the half dozen students. Try and build things in where students have to engage with each other. So we have the lecture. What can we do with the lecture? Let's fundamentally change the lecture. Okay. We'll flip the lecture. See what I did there? Flipping the lecture is this idea that we take the time we would normally spend on the lecture face to face and we do stuff in that time. We do activities. It could be stuff similar to what you do in your peer learning group. It could be solving problems, but it's stuff that requires people to be together synchronously, talking and doing. It's not just a transmission lecture. And we take the lecture and we still value it, but we record it, we chuck it up online, get them to watch that before they come to class. You could describe this unit as a flipped lecture unit. We can also do bite-sized lectures. That's someone taking a bite of the lecture. With a bite-sized lecture, you chunk it up into short segments, maybe 10, 15 minutes, probably not 20. These are things that you can watch on the train. These are things you can watch on a mobile device. You don't need a lot of time. You might be able to watch them over the course of a week. They would normally end with some sort of a prompt to do something, to go talk to somebody about the content of the lecture. The bite-sized lecture approach could work well with the flipped lecture approach. So these are things that people are right now doing and experimenting with the lecture. Of course, the other thing people are doing is getting rid of the lecture completely. Do we always need to have lectures in our units? You get to talk about that in your groups this week. So let's go back to what's the use of lectures. Well, the lecture is as effective as other methods to transmit information. Let's use lectures for that. But if we want discussion to promote thought, well, let's do that in a tutorial. Let's do that somewhere else. The promoting of thought is not best suited to the lecture. And lectures are ineffective for the change stuff, the inspiration, the skills. They're not that great for that. So when considering lectures, let's think about the learning outcomes of our unit, and if those learning outcomes are best suited by lectures, let's use lectures. If not, let's see if we can use the time to do something else. And that's the focus of next week, is of course alternatives to lectures. But the challenge for this week: act on one of those cognitive principles. It could be going through your slides and finding that one slide where you've got that really important long block quote, finding some other way to work with it. It could be adding in a graphic and talking to it, but act on one of those cognitive principles. Try and do some sort of active processing activity with the students every 20 minutes. Could be one of the ones we've talked about, could be something else you discover from people in your group. And weed out some of the nice to have content. Some of the stuff that's great, that you love, but isn't really necessary for the unit. And when you're doing all of this, think what worked for me, write it down and use it. Maybe for the first assignment, maybe for the third assignment, maybe for both. So I hope you do take me up on this challenge this week. Have a chat with people in your group about it, and I look forward to hearing about your changes, adaptations to your classes. Of course, you're probably doing a lot of these things already yourself, and I look forward to hearing about those as well. Thanks a lot.